record. So we have 7 different rules. One of them is not in the formula chart. You'll see which one it is later, but today we're going to start with product of powers. Okay, we're going to start with product of powers, but before we start that, you actually need to know the parts of it. And where is my movie? So the very first day of school, probably second day of school, we learned how to do what that very first week? Combine what? I actually want y'all to participate. Combine what? Combine like terms. Combine like terms. Now, a term had different parts. Okay. So say 2x is the term I'm talking about. This 2 in the front is known as my what? Participate or the video is going to suck. The 2 in front of the x is called the what? The coefficient. Coefficient. The x in 2x is called the variable. Everything I write, you write. I see a lot of staring. Variable. Now, when we put those two together, they're called my, what are they called? What is it called once it's put together? What's the last word that you just said? Term. A variable with a coefficient, whether it's invisible or not, a variable with a coefficient put together is called a term. Now, b to the power of n and 2 to the power of 3 is called a power. Okay. Now, this n, one of the very most important things that you need to realize or you need to understand is that this n is not the same size as the b. This 2 is not the same. I mean, this 3 is not the same size as the 2. These two numbers, n represents a number. These two numbers are located in the upper right-hand corner of the b and the 2. And they are both called they are called exponents. It's not like 2x where b is going to be my coefficient. B and 2 are both called my base. B and 2, these are going to be called my bases. Okay. Now, just like whenever I put the coefficient and the variable together to make my term, I put my base with my exponent, put them together, and it creates a power. So when you have a number or a variable raised to an exponent or with an exponent combined, they make a power. All right, so the exponent is going to tell us how many times quantity, I'm gonna put QTY, how many times the base is going to be multiplied and since we wrote the word times twice, I'm just going to write by itself. The exponent tells us how many times in quantity you're going to multiply the base by itself. We're multiplying the same base every time. So 2 to the power of 3 is not to be confused with 2 times 3. Remember, we use the dot to represent multiplication, or we use parentheses because, I thought that was my pen. Because an x can be confused with a variable. So 2 to the power of 3 is actually said or written as what? What is 2 to the power of 3? If you it's not 2 times 3. We're multiplying the base times itself or by itself this many times. The base is 2, multiplying it by itself this many times, yes. So it's actually 2 times 2 times 2, not 2 times 3, not to be confused with 2 times 3. Now, when we work this out or simplify it, reduce it, 2 times 2 is what? And 4 times 2 is 8. So 2 to the power of 3, notice, is not 2 times 3. 2 times 3 is 6. 2 times 2 to the power of 3 is actually 8. 2 times 2 times 2. Okay. Now, 3 to the power of 2 is not 3 times 2. It's what? 3 times 3. And I'm actually going to write it out to the side for a reason. And 3 times 3 gives me, and I'm going to work my way down, not across. I'm doing it once again for a reason. 4 to the power of 3 is not 4 times 3. It's, let me just move it out to the side. 4 times 4 times 4. Now, what do you get when you multiply 4 times 4 times 4? What's 4 times 4? And 16 times 4. 64, Ms. Ramirez. Yes, 64. Awesome. 64. I'm glad you guys stayed sharp on your math skills while we were gone. What's that? If not, try to come in the morning. Try. You ready? All right. So now this power or this exponent of 2 and the exponent of 3, yes, they are both exponents, but they have a very, very specific special name. The exponent of 2 is called what? Yep. Not a trick question. Squared. Squared. So you say it as 3 squared. 4 to the power of 3, that power of 3 is cubed. Make sure you write the D at the end, ED, cubed. Okay. Now, everything on this little half sheet is just rules that you need to know before actually getting into the good stuff. Okay. Now, if a base, next bullet point, if a base does not have a written exponent, if it's missing an exponent, it is what? Understood to be what? A 1. So you can have a base by itself or a number by itself, a variable by itself. Notice we don't have an exponent. You fill it in with the number 1. 3 is the same, equals means the same. 3 is the same exact thing as writing 3 to the power of 1. Or look at it, look at this in terms of variables. XY squared Z is the same or the exact same thing as writing it as x to the power of 1, y squared, z to the power of 1. Just because you don't see the exponent doesn't mean it doesn't exist, just like whenever we had coefficients, okay? Same thing. Now, the reason we call this laws of exponents, the whole unit is called laws of exponents, and we're learning different rules. Laws of exponents, the change or it's affecting the exponent, not affecting the base. Everything that we do this week is going to affect the exponent. And I'm going to repeat that over and over. I'm going to sound like a kindergarten teacher, but it's because this is the most basic one. You need to know this one to move on. So negatives. Negatives are a little bit special. Let's look at when to include a negative and when to not include a negative. What is the biggest difference here? How do we know when to include a negative? What is the parentheses? Now, parentheses serve 2 different purposes. Tell me what those 2 purposes are if you know them. One of them should be obvious. Multiplying, but also parentheses serve as, they're considered a grouping symbol. They're used for grouping variables and numbers together, or they're used for grouping terms together. Meaning if I use the parentheses is because I want that negative to be included with the 2. So -2 to the power of 4 is written as what? Correct. -2 times -2 times -2 times -2. And when it's included and not included, you end up with two different answers. So we're going to look at both of them. What happens when you multiply -2 times -2? What do you get? +4. I have another pair of -2, so I'm just going to go ahead and multiply those. -2 times -2, +4. There's still a multiplication symbol between them. So 4 times 4 gives me +16. Let's see the difference between including it and not including it. And this only affects even numbered variables. I mean, exponents, not variables, even numbered exponents, but still need to know how to do this. So notice there's no grouping, there's no parentheses. So that means that the negative is not included. So my actual power is just 2 to the power of 4, not -2 to the power of 4. That negative is going to stay out in the front while I'm going to go ahead and group this, multiply 2 times 2 times 2 times 2. There's my power of 4. And I already know this. 2 times 2 is 4. 2 times 2 over here is 4. What's in between everything? Multiplication. And 4 times 4 is 16. Now, I'm still grouping it together because I have to make sure not to include that negative. At least not yet. I'm going to bring it down, bring it down. This cannot be my final answer, but we did learn last semester what to do whenever you have a negative right beside a parentheses. What can you do? What's happening in between them? What do you put in between? A 1. Now, if you have a number in front of the parentheses, what do you do with that number? You multiply. So -1 times 16 is -16. And notice how when you include the negative and when you do not include the negative, you end up with two totally different answers. Having +$16 and owing somebody $16 are two totally different situations. That's how important those negatives are. But don't freak out. That's why we have calculators. Calculators are here to help us whenever we have to deal with, do I include the negative? Do I not include the negative? Oh my gosh, I'm freaking out, right? So here we go. Clear. Let's see what happens if we're going to look at this versus this. You can, since it's just numbers, if it had variables included in it, you wouldn't be able to do this, but we just have numbers. So I'm going to type in my parentheses and go ahead and try this. I've already showed you guys how to find the squared. Squared is right here. If you wanted cubed in the math option, cubed is option 3, but there is one that works for everything. So here's my -2. You press the button right under clear. It's called the caret. I believe I've showed you that before. And it gives you that little box so you can type in any exponent. And it works for 2 and 3 if you forget about the x squared in math. But mostly it's used for anything above the 3. So 2 to the power of 4. And notice it gives you that +16. So you avoided having to do this work. And then if I do not include it, -2 to the power of 4, notice we get the -16. So two totally different answers, two totally different situations. Got it? Once again, these are just rules. These are just tools that are going to help you understand the very first part of this. Okay. Moving on to the booklet. Booklet number 1 of the week. Here we go. I'm just kidding. So once again, I'm going to repeat myself over and over and over until you get sick of hearing it. Laws of exponents. They're the laws of exponents. They're not the laws of bases. The laws of exponents, the rules that apply to exponents only. The first rule that we're going to learn is the product of powers. Now, I like to break these phrases down. That way you guys understand what we're doing and where is it coming from. So product. What does the word product mean mathematically? Not word problem wise. What does it mean to take the product of something? Do what? word problem product. What mathematically, what would you do if you're taking the product of 2 and x? What would you do? You what? The product? Of course you've heard it. You heard it all last semester, people.
I remember that. I can't think of the name of it.
We multiply. Product means to multiply.
Yeah,
Reuben was like, man, I never knew that, even though Mr. Ramirez repeated it like a million times.
Yeah.
Multiply powers. Notice that word is plural. What does it mean for something to be plural? More than one. But we just learned that a power is a base with an exponent. There's a power, but if I multiply powers, I need at least how many? 2. So multiplying 2 powers. Can I have 3? It's plural. Yeah, I could also have 4. I mean, I could have 3, I could have 4, I could have 5, as long as it's plural. What happens when you multiply 2 or more powers together? What do you do to the exponent? Because this is the law or the rule of exponents. Okay, so let's look at this table right here. The very first column is already filled in for you, but I'm still gonna, explain a little bit from it. But is everybody okay with the terminology here? All right, so everything that we do, our answers are going to end up being expressions. What's the difference between an expression and an equation? An expression does not have what? That no equal sign. An expression has no equal sign. So I don't want to see answers written as x equals something or 3 equals something. Expressions do not have equal sign. We're not working things out that way right now. All right, so 3 squared. We're going to practice using that terminology. 3 squared, once again, is not 3 times 2, it's what? 3 times 3, and I'm going to just use these first 2 3s right here. I'm going to put a little 2 under it to represent that squared. So this is 3 squared written out the long way, but it actually wants us to multiply 3 to the power of 5. And 3 to the power of 5 means I'm going to multiply the number 3 how many times? 5 times. 1, 2, 3, 4, 5. What do you know? It's already written out there for me. And now notice that you're multiplying the same number over and over and over again. So if I put it together, if I put it back together, I'm multiplying the 3 how many times? 7. Okay. And that is expanded and exponentially. Now you don't have to use expanded form on your assignment, but it might help. It will not help once we get into exponents like 25. So you might want to learn the short way as well. All right, now 2 times 2 to the power of 6. Something's missing here. What's missing? Your exponent. If you have a base, a big number, not the little one, if you have a base missing an exponent, you put what number? 1. Now 2 to the power of 1 means we're going to multiply that number 2 1 time. Very important that you think about multiplying that 2 1 time and not 2 times 1, because I had somebody say 2 times 1 earlier. So it's just multiplying that 2 1 time. I'm put a little 1 there. And then it wants us to attach 2 to the power of 6. It wants us to multiply 2 how many times? 6 times. So 1, 2, 3, it might not fit, 4, 5, 6. Now I'm going to draw my little box under it. That way I know this is where my 6 is coming from, 2 to the power of 6. Now, I'm multiplying the same number over and over and over again. So essentially, I'm multiplying 2 to the power of 7. What about with a variable? I'm going to switch colors so I don't confuse it with these 2's. What about with a variable? We have b to the power of 4. So how many times do I need to write that b? 4 times. B times b times b times b. 4 times. Okay, I'm going to put a little 4 under it. There's my exponent of 4. Now we want to attach b cubed. How do you write b cubed? B times b times b 3 times. So we're multiplying, essentially, we're multiplying the same base, or we're multiplying b how many times? 7. So look at that question below. They're all 7. Yes, they are all 7. There's 3 different ways of getting that exponent of 7. So look at it. Compare the very first row with the very last row. Ignore what's in the middle, because that's something that you're not really going to use. It's just helping us see what's going on here. It's helping us discover the rule. So what stayed the same? What changed? The what changed? The very. Which number? If you look at this row here and this row here, what changed? We're not using equations because it's an expression. There's no equal sign. Okay, let's start something simple. There's something that's the same here as here. What stayed the same? The what number? Look at your parts. You have the base. What is the base here? On 3 squared, which one is my base? On 3 to the 5th, what's my base? In the answer, what's my base? So the base stayed the same. 2, 2, 2, B, B, B. My base is staying the same. Remember, laws of exponents, it affects the exponent only, not the base. So base is going to stay the same. Base stays the same. Okay. What did change and how did it change? Try to use the proper term. The exponent. So how did we go from 2 to 5 to 7 to 1, from 1 to 6 to 7, from 4 to 3 to 7? What happened with those numbers? They were added. 2 plus 5 equals 7. 1 plus 6 equals 7. 4 plus 3 equals 7. So when we multiply 2 powers and the base is the same, you add the exponents. Add the exponents. You add the exponents. Once again, laws of exponents, rules of exponents, it affects the exponent only, okay? So this is how the formula is going to be presented to you on the STAR test and in your formula chart. A to the power of m, that's a power. A to the power of n, that's a power. Both together become powers. We're multiplying 2 powers. So what do we do with the exponent? We add them. So if I add my exponents, it becomes what plus what? M plus n. M is the power here, or m is the exponent here, n is the exponent here, m plus n. And that's how it looks on your formula chart. I'll come back to it. Here it is. Whether the dot is in between them or not, they're both multiplied. Here's a power, here's a power. So base stays the same. The A is still an A. Exponent, exponent, added. Everybody see that? You need to know how to use your formula chart. Okay, so power, powers multiplied, add the exponent. Okay, ready? Think you're ready? Maybe? All right, here we go. Let's do some examples. Here's the very first one. I'm going to zoom in. So now that we've discovered the rule in product of powers, if you're multiplying 2 powers that have the same base, you add the exponent. If they have the same base, you will add the exponent. Okay, so here's a power. Here's 2 powers they're being multiplied. So what stays the same? What is my base here? And what do we do with the exponent? So what do we add? 2 plus 3. Now, instead of jumping straight to the answer, make sure you write in this step. Yes, do it in the notes. I don't care if you do it in the assignment or not, because if you miss it, you miss it. If you jump that, and if you miss it because you jumped that step, that's on you. 2 plus 3 is 5. But I do want it written in the notes, because if you ever have to go back to your notes, you need to know why or where you got that 5 from, okay? All right, example B. And that's it. It's not W equals 5. It's not 5 equals W. It's just W to the power of 5. No equal signs anywhere, okay? So -5 to the power of 5, power, -5 squared, powers, and they're multiplied. So what stays the same? What is my base? -5, and what do we do with the exponent? So 5 plus 2. And what does 5 plus 2 give me? -5 to the power of 7. Now, this is where, well, it doesn't get a little tricky, but on the STAR test, your answer can either look like this, or your answer choices might take it a step further, and it might ask you to simplify, or it might ask you to type this in. If I type this into the calculator, am I going to include parentheses, yes or no? No, they don't exist here, shouldn't exist here. So -5 to the power of 7, -78,125. It can be a bubble in answer where you're bubbling in -78,125. Either one of those could be answer choices. You could see it both ways. Now, the only reason we type this one in the calculator and not this one is because this one has just numbers. This one has a variable. You cannot type a variable on the home screen. Got it? Questions so far? All right. Example C. I'm not going to keep drawing the little boxes under them, but we have power, 2 powers, multiplied. So what stays the same? What's my base? And what do we do with the exponent? So what do we add? And what is 4 plus 4? B to the power of 8. Can't do anything else. We're done. Some of your answers are going to look weird. D. Power, 2 powers, they're being multiplied. So what stays the same? What is my base? And what do we do with the exponent? So 2 plus 7. What is 2 plus 7? N to the power of 9. Ooh, that's ugly, but oh well. I hope the people, there's a lot of absences, so I hope the people watching this at home know that that is an N. We good so far? All right, what's the difference between the examples we've just completed and the ones that are coming up? Do you think anything's going to change with the procedure, with the steps that we need to take? No, it's just adding another power. 2 are already plural. 3, it continues to be plural. There's nothing different, but there is something missing. What's missing here on E? Which exponent? The middle one. What do we put? Now we're multiplying 1, 2, 3 powers with the same base. So what stays the same? What is my base? And what do we do with the exponents? So 3 plus 1 plus 4. Yes, you can add 3 numbers at the same time, believe it or not. And what is 3 plus 1 plus 4? 8. Done. Keeping it sort of simple today. F. 2 things missing. What's missing? Make sure you fill in any exponent that does not exist. Okay. So base stays the same. What is my base? And what do we add? And what do we get? K to the power of 4. All right, questions before we move on? Okay. Now, Now we're taking it up another step. What is the difference between the examples we just did and the one that's coming up? Okay, so X is a variable, but Y is also a variable. I heard the word parentheses. Would parentheses mean anything different than the dot? No, the dot and the parentheses both represent what? Multiplication. So you're still multiplying multiple powers. So what is the difference? Even if only one of the powers is in parentheses, or if only two of them is in parentheses, same thing. You're still multiplying 3 powers here. What's the difference? Here's variables. And what? And a number. Notice this 2 is not the same size as this 2. This -3, not the same size, not to be confused. So we have 2 different types of powers. We have one group of powers where it's just numbers, where there's, just numbers, coefficients, and the other group of powers are going to be in the form of a what? Variables, right? So the easiest way to tackle these whenever you start getting into multiple step, and this one's going to be like, what, 2 steps maybe? So the easiest way to tackle these is to group the things together. So I'm going to make how many different groups? We have 2 different types of powers, Ruben. So I'm going to make how many groups? 2 groups. So in my first group, I'm going to just go ahead and go from left to right. I'm going to take that 2 is in parentheses. So I'm going to go ahead and leave it in. What can I group with that 2? What else is just a number? 2, this 2 and the exponent of 2 are not the same. Correct, the -3. Notice the 2 and the -3, they're the same size, they're in the same location. Now, this is where I wrote a note earlier. I forgot to write it there first, so I hope they don't hate me. 2 and -3, those are considered coefficients, right? Coefficients, I'm just gonna write coef. Coefficients, I've talked about it, I've repeated it a couple times. This 2, not the same size as this one. This -3, not the same size. Coefficients and exponents are not equal. They are not the same thing. They are not to be treated the same way. Exponents. Laws of exponents apply to exponents only. The rules apply to exponents only, and these are not exponents. So since they're in parentheses, what am I going to do with these 2 numbers? Multiply them. So 2 times -3 is -6, and I cannot do anything else with this group. But I can start another group. What can I group with x squared? X cubed. And now this should look familiar. 1 power, 2 powers. We're multiplying them because parentheses mean multiplication. We're multiplying 2 powers with the same base. So what happens? You add the exponent. Base stays the same, and you add the exponent. 2 plus 3. Don't skip a step. And 2 plus 3 gives me 5. Now, there's nothing else I can do with this. Once you're done working through each group, you can just go back down to the bottom or go to the very end, put them together. And that is your answer. -6 times x to the power of 5. Okay? 4 more examples, just like this one. Ready? Questions? Biggest takeaway on this example, coefficients and exponents are not the same. They are not to be treated the same. Example A. How many different groups are we going to create here? 2. My first group can have what times what? 6 times 2. And 6 times 2 gives me 12. I've reached a stopping point. My second group is going to have what times what? X squared times x to the 4th. Thank you for using your terms. X squared. Now we're multiplying 2 powers with the same base. Base stays the same. What do we do with the exponent? Add them. So we get x to the power of 6. Nothing else to do with that. nothing else I can do with that. So move on down, put them together. 12 to the power of 6. Example B. What's in my first group? 6 times 5. And what is 6 times 5? 30. 35 is 7 times 5. And what's in my next group? V what? Cube. Thank you for using your returns. And times V to the power of 5. Multiplying 2 powers with the same base stays the same. And we do what with the exponents? And 3 plus 5 gives me, once you're done working it out or simplifying it as far as you can, just go back and put your groups back together again. Don't forget to put it back together. Questions? All right, moving right along. I always find it helpful to separate my groups, then put them back. What's in my first group? Can I have more than 2 groups? Yes, you can. Sometimes you're going to have a coefficient, but also 2 or 3 variables. So yes, you can have more than 2 groups. What's in my first group? 2 and 4. And 2 times 4 is? And in my second group? Correct. We're multiplying 2 powers with the same base. So base stays the same. What do we do with the exponent? Add. And 2 plus 3 is 5. Done with that a to the 5. There's nothing else to do in that group. So let's put our groups back together again. 8, a to the 5. Once again, these are expressions. There's no equal sign. So yes, it's going to look a little weird. Last one. Last one. What's in the first group? -7 and 3. What is -7 times 3? Do I add those?
No,
Why not? Ah,
because it's a negative.
because what? Because it's a base. Laws of exponents apply to exponents only. The adding applies to exponents only. Now, we're not only going to add the whole week, so that's why I keep repeating myself. Now we have x squared times x squared. So multiplying 2 of the same base, you add the exponent, 2 plus 2. And x to the power of 2 plus 2 is 4. Nothing else to do, so let's put it back together. -21, x to the power of 4. Now I'm not going to do the last 2 examples because those actually go with tomorrow's lesson, okay? So you are on your assignment, you're going to do just 1 times 6, 1 through 6.